Okay, now in this video I'll be showing you guys on how to solve correlation and some shortcuts, short rules. So, sorry, I'll be telling you guys on short rule on correlation. Please take note. But all you just have to do here is to hit the subscriber button and get all our courses in terms of statistics. Please take note. Okay, but let's take note of correlation here. But before correlation here, you have to watch our previous video, that is regression. Please take note. But let me just try to illustrate on the difference between correlation and regression. Now sometimes maybe I might have two persons. Maybe I have a person A and person B, and again let me just say three persons: person A, B, and C. And A, B are friends, but not that closer friend. And at that point, since they are not close, they might not be able to ask themselves maybe the age. You get? Please understand this, please. Might not be able to ask themselves their age. But at a point they are closer. Please take note. At a point they are closer, they can be able to ask themselves their age. Please take note. So the same thing here, difference between correlation and regression. In terms of solving regression, we solve it what? Indirectly. But in terms of solving correlation, we solve it directly. Please take note of that. Please take note. Okay. Now, what is correlation here? Please write. Correlation can be defined as the measure of the degree. Please write. Correlation can be defined as the measure of the degree between the dependent variable and independent variable. The measure of the degree between the dependent variable and independent variable. Okay, now we are going to look into the method of correlation here. Please take note, and also the range of correlation. Okay, now we are solving correlation. What are the methods we use in applying correlation here? Okay, please write method of correlation. Okay, we have number one, we have Pearson product moment correlation. We call this PPMC. Please take note. The next one here, we call this Spearman's ranking correlation. Is also known as ranking correlation. Please take note. That's ranking. Okay. Now we are going to treat this guy and also treat this guy here. But this is what you should understand here. Sometimes you'll be giving some questions on correlation, and maybe the method might not be specific to you. That means they will not tell you the method to use. Please understand this. In solving correlation here, they will tell you either is PPMC, that is a Pearson product moment correlation, or Spearman's ranking correlation. But sometimes also it might not tell you the method to use. Now, whenever the method is not specific, we use our what? PPMC. Whenever the method is not specific, we use PPMC. Please take note of this. Okay. Now let's look into the first one here, class. The first one here, Pearson product moment correlation. The first one here, Pearson product moment correlation. Now we are saying about Pearson product moment correlation here. Please take note. The correlation here, R here, is said to be, the formula is said to be n sum of s y minus sum of s sum of y over square root of n sum of s squared minus sum of s all squared, that is only for s, into, let's go to y here. Please take note. That is n sum of y squared minus sum of y all what? Squared. Okay. Now this formula take after the formula of beta 1. But in this case here, there is square roots, remember, and there is what? The part of what? Y. Okay, please just understand this. This is n sum of s y. You scatter the stuff, that is minus sum of s sum of y over square root of n sum of s squared minus sum of s all squared. You put your open bracket here, n sum of y squared minus what? Sum of what? Y all squared. Please take note. Okay, we are going to know how to apply this formula here in solving some questions. Okay, but before then, we are going to actually know much on the range of correlation. Now, what are the range of correlation here? Correlation is ranging from -1 to what? 1. Please take note. Okay, please take note of this. Note that correlation R here is ranging from -1 less than or equal to R here, less than or equal to slash 1. So the range of correlation is between -1 and what? 1. Please take note. Okay, from this range here, we can easily interpret correlation. Now, that means we have to know how to interpret any correlation at all. When it's said to be a strong correlation, when it's said to be perfect correlation, when it's said to be strong weak correlation, when it's said to be perfect positive correlation. Okay, now, or perfect negative correlation. Okay, so let's try to understand how to interpret correlation. Please write interpretation of correlation or degree of correlation. Please subheading interpretation of correlation or degree of correlation. Focus more on degree of correlation or interpretation of correlation. But before we do that, let's go back to the range of correlation. Okay, now correlation, we use arrow to represent correlation. Either capital letter or small letter is valid. Please take note. So we say that the range of correlation is said to be -1 and 1. Please take note. That means we also have other numbers after -1. That is -1 less than arrow, or what? Arrow less than what? -1. That is the less value and what? The greater value. Please take note. But that's not an issue here. The issue here is to understand how to interpret correlation here. Please understand this, that whenever correlation, please take note, number one, whenever correlation, whenever arrow here, let's just use arrow, is equal to 1, is called perfect positive correlation. Please take note of this. We are trying to choose the between here, the between value here. We have chose this one here, that is 1 here. So when you do that, when r is equal to 1, is called perfect positive correlation. So positive means that there's invisible plus here. Please take note. So that is for this. Now 2, when ever r is equal to -1 here, is called perfect negative correlation. Please take note of this. Okay, now number 3. Okay, now it's not for us now to understand this, that for r less than -1 here, there are some values less than -1. Now, what are the values less than -1 here? Now, any value less than -1, listen to me, please. Listen, please. Any value less than -1, depending on the value here. If I divide this guy here, listen. If I divide this guy here by 2, is going to be, that is half of this guy here. Is going to be obviously 0.5. All right. That means it's still close to perfect, but it's not perfect. Okay. Now divide this guy here by 2 here to get the value here. I'll get minus. Please take note. I'm trying to half -1 there. Is going to be minus, that's minus 0.5. That means whenever r is equal to minus 0.5 here, is called, please take notes, is called is called strong negative correlation or moderate correlation. Okay, now whenever r is equal to minus 0.5 here, we call this strong negative correlation or moderate correlation. I'll prefer you guys here to call it maybe moderate negative moderate correlation. Very important there, because we also have some values that are less than what minus 0.5. Now what about some values that are less than minus 0.5 here? Okay, let's look into that. All right, now let's go back here again. Listen, please. They say whenever r is equal to 1 here is called perfect positive correlation. Please remember that we are trying to take from here minus 1 less than equal to r here, less than equal to plus 1. From here, we can now form all the values here. Okay. Now, whenever r is equal to minus 1 here, that is we have interpreted for this side here, that is equal to part. Now, for equal to minus 1 here, we say whenever r is equal to minus 1 here is called perfect negative correlation. Please take note. Now, the last one here is, I want to get the half of this guy here, starting from negative. Half this guy here, okay, I'm going to get minus what? 0.5. So whenever r is equal to minus 0.5 here, it's called strong negative correlation or moderate correlation. Now, any value greater than, listen to me, any value greater than minus 0.5 should be weak negative correlation. Please take note. Now, whenever r is greater than minus 0.5, whenever r is greater than minus 0.5 is called weak negative correlation. Okay, let me explain this guy here. Remember that minus 0.3 is actually greater than this guy here, all right? So any value that is greater than minus 0.5, that is 0.2, minus 0.2, minus 0.1. So any value greater than this minus 0.5 here should be called weak, please take note, weak negative correlation. Please take note of that. So the next one here is, let's get a positive area here. Now have this by 2. This will be whenever r is equal to 0.5, please take note of this, is called strong, we have positive here, positive correlation. Please take note. Or positive moderate correlation. Okay, you can actually get this guy to be negative moderate correlation. Please take note. Now the next one here is whenever r is maybe greater than, listen to me, 0.5, any value greater than 0.5 should be obs class strong positive correlation, strong positive correlation. So whenever r is greater than 0.5 is called strong positive correlation. Okay, now that means from this particular range here, we are able to form about 6 conditions or 6 interpretation of what? Correlation. This one here, whenever r is equal to 1, is called perfect positive correlation. Whenever R is equal to -1 here, it's called perfect negative correlation. Whenever R is equal to -0.5 here, it's called strong negative correlation here, or negative moderate correlation. Okay. Now, whenever R is greater than -0.5, now this one looks so confusing to some persons here. But that -0.5, sorry, -0.3 is greater than -0.5. So whenever any number that is greater than this guy here is called weak negative what correlation. Please take note. Now whenever R is equal to 0.5 is called strong positive correlation or positive moderate correlation. So whenever R is greater than any value greater than 0.5, just like 0.6, 0.7, 0.9 is called strong positive what correlation. Okay. Now let's try to solve a particular question here and understand this. But just know this: in terms of interpreting correlation here, you can either use Pearson product moment correlation or what ranking correlation. Please take note. So either ranking correlation or Pearson moment correlation can either be used to calculate our what correlation. Of this question here, question 1, under correlation, it said compute the correlation coefficient between x and y using the data below and interpret the results. Listen, these are the values here. For x is this, for y is this. If you look into the equation here, they did not give us the method of correlation here, and which I told you guys that we have two methods, that is PPMCC, that is Pearson product moment correlation coefficient, or ranking correlation, that is Spearman's ranking correlation. So if you are asked to calculate any of them there, it means that they must tell you the one to use. But sometimes, please understand this, sometimes the method might not be specific. If the method is not specific there, it means that you have to use what? PPMCC, that is Pearson product moment correlation. Okay. Now if you look into this question very carefully here, the method is not specific. So using PPMCC here, I'm going to have this to be our correlation coefficient here. Please take note, will be equal to n sum of xy minus sum of x sum of y divide by square root of n sum of s squared minus sum of s all squared. Okay, sum of s all squared, that is for s. Now we move to this. This is said to be n sum of y squared, sorry for this, minus sum of y all squared. Okay. Now from this particular formula, now we can from this particular formula here, we can easily recreate this guy here. We have to get sum of sy, sum of s, what again? Sum of y, and also we have to get sum of s squared, what again? Sum of what? Y squared. So now let's try to recreate this particular table here to get all the values and replace into that particular formula. Okay, let's do that, please. All right, now let's try to recreate that particular table here in order to get these values here. Okay, now let's go, please. For s, okay, for s and for y, let's get the values first. Sorry, I'm coming. Okay, now what are the values for s, please? That is 2, sorry, what again? 4, okay, what again? 7, okay, what again? 8, okay, what again? Okay, that's all. Okay, for y? 3, yes. 7, 12, 7, right? Now, if you look into this here, we have gotten s. These are the s here, the values of s here. These are the values of y here. So we can easily get sum of s and sum of y. Okay. Now sum this. This plus this plus this plus this. What is the answer here? Let's just sum this plus this to get the summation here. Sorry. To get the summation here, this plus this plus this plus this. What is the answer, please? That is, I have 21. Now the same thing here. Let's to get the summation of y. This plus this will give us 10 plus this 22 plus this. What is the answer, class? 29. That is 29. Okay, that means we have gotten these two guys here, sum of s and what? Sum of y. Let's get this guy here. To get sum of sy, you have to get sy first before the total. Please take note. So our sy here mean times s with what? Y. So this times this what? 6. What about this guy here, please, class? 20 what? 4. All right. What about this guy here? 28. Sorry. What about this guy here? 4 times 7 sub class 28. Please take note. Now, what about this guy? 7 times 84. 84. Let's go here. 8 times 7 is what? 56. Okay. And let's get sum of sy. What is sum of sy here? Let's go here. This times this times this times this. What is the answer, please? That is this plus this. Sorry, not times, please. This plus this plus this plus this. What is the answer, please? That is 174. Right? Now that means we have gotten this guy here, class. The next is to get s squared. Okay. Now for s squared here, it means that as you square anything about s, this will be 4, 16, 49, 64. So the sum of, let's go here, s squared will be equal to, class, sum of s squared means this plus this plus this plus this, class. 1, 3, 3. So if you look here, we are not only having sum of s squared here, we're also having this one means sum of s all squared. Sum of s is already there. So if you square that, that will give us here. So let's go here. Sum of y squared. Before we get sum of y squared, we have to get y squared first. So getting y squared here, it means that I should square everything about what? Y. So this is going to be 9, what again? 49, what again? 144, what again? 49. Please take note. So let's get the sum of y squared, class. Sum of y squared means this plus this plus this plus this. What is the answer, please? This plus this plus this plus this. What is the answer, please? That is 251. All right. Okay. Now, okay, that means I've gotten all the parameters needed to solve for this guy here. The only thing is to replace. So our coefficient of regression here, that is PPMCC, is said to be equal to, class, n is the frequency of s and y. That is a pair number of s and y. 1, 2, 3, 4. Am I correct? So this is going to be 4 into, what is the sum of sy? Please take note. What is the sum of sy? 174 minus, what is the sum of s? 21. What is the sum of y? 29. Okay. Divide by square root of, please take note of this. 4, this is my 4 here, into the sum of s squared is said to be 133 minus the sum of s is said to be 21. You square this, it's already squared, please take note. Now into 4 into the sum of y squared. The sum of y squared is said to be 251. Okay. Minus into the sum of y is said to be 29. That is 29 all what? Squared. Okay. So the next thing here is for us to evaluate. So now let's try to evaluate this guy here. That is this times this minus this times this, and also evaluate this guy here. How do we do that? We have to evaluate this inside one first and this and multiply them together. Okay. Now let's do that. Try to evaluate that. That is, I will see here will be equal to, class. Okay. Now 4 times 174. What is the answer, please? 696. Like this. Minus, okay, Now let's go here. 21 times 29. That is 504. Okay. Divide by square root of. Let's evaluate this. Now 4 times this. That is 4 times 133. That is 532. Okay. Minus 21 times 21 all squared. 21 all squared means repeat 21 into 2 places. That is 21 times 21. What? That is 441. Okay. Into, let's go back to this guy here. Now 4 times 251. What is the answer, please? That is one what? 1004 minus 29 all squared. That is repeat 29 to 2 places. That is 29 times 29. Okay. That's what? 841. Okay. Now the next here is to simplify again. That is this is equal to plus this minus this. That is 696 minus 504. What's my answer there? 696 minus 504. What's my answer there? 696 minus 504. What is the answer there? Sorry? That is 192 over square root of, please look up here, please. Now 532 minus 441, sorry, 91 into this 1004 minus 841. What is the answer, please? Sorry, 163. Okay. Now totally here, look at what you have to do here. Look up here. 91 times 163, square root of the result there. We can now write it down. That means it will be equal to 192 divided by, what is the result there? Yes, square root of that. 1.790 like this. Okay. That means totally here, our regression here, that is using PPC, is equal to this guy 192 divided by 121.790. Class, what is the answer, please? I will have this to be, all right. Sorry for the confusion here. Okay, let's correct the mistake here. Listen, 21 times 29 gave us 6 what? 09, right? So it's said to be this. Let's correct the mistake here. That is 609. Am I correct? Okay. That means everything here will give us this 696. Okay. Minus, I'm very sorry for the mistake. Minus 0. Minus 696 minus 609. What is the answer here? Sorry. That is 87 here. Please take note. So this guy here will give us 87 divided by 121 point what? 0.790. Please confirm. Okay, that is this times the square root of that will give us square root of the answer here will give us 121.790. That is, this will give us 0.71 only. Okay, just call it 4 3. That is 4 decimal place 1 2 3 4. Now most of the times whenever you are giving this anything that is in decimal places and there is no required decimal place to end, you always end at where 4 decimal places. That is the reason for your 4-figure table. Please take note of that. Okay. Now in terms of listing, in terms of correlation, we don't approximate values. Please take note. Now this is 0.7143. With the interpretation here, that means it's close to 0.7. Am I correct? And we are going to interpret this to be strong positive what? Correlation. So this is going to be strong positive correlation. Please take note. I have this to be strong positive correlation. Okay. Okay, in this video, we'll be looking into Spearman's ranking correlation. Okay, now earlier before now I told you guys that we have two methods in solving correlation. We have Pearson product moment correlation, and the next is said to be Spearman's ranking correlation, or you can say ranking correlation. Okay, now what is the expression here? So that the ranking correlation here is said to be equal to 1 minus 6 sum of d squared over what? N into n squared minus 1. Please take note. Please take note of this formula here. This 1 minus 6 sum of d squared over n into n squared minus 1 is not in any way like this 1 sum of d square over n into n square minus 1. So this guy and this guy is not the same. Now let me explain this guy here. This guy here means that after solving this guy here, everything here is subtracted from what? 1. Please take note of that. So this guy and this guy is not the same. Please take note of this. Okay, don't. Okay, now let's try to understand the parameters here. Of course, the sum of d square here is said to be the difference. This d here is said to be the difference in the ranking. Please take note. So that means our diff is said to be arrow s minus what? Arrow y. Okay. Now arrow s here means ranking of s. Arrow y here is subclass ranking of what? Y. Please take note of this. We are going to know them here. While this m here is the what? The number of the pairs between s and y, or the frequency of s and y. Please take note. Okay. Now, but understand this. A ranking either x or y depends on if it is going to be in ascending order or what? Descending order. But this is what you should understand here. Before you rank that to be either ascending order or descending order there, you should know the least order of arrangement in the equation. Okay, now let's try to know this. Example 1, please. All right, let's solve example 1 here so that we can easily understand everything about Spearman's ranking correlation or ranking correlation here. Example 1 here. Obtain the Spearman's rank correlation coefficient for the data given below. These are the data here. There is 2, listen please, 2, 4, 7, 1, 6, 8, 2. All right. Now y is given to us as 4, 7, 1, 6, 7, 5, 6. And the only thing here that is a kind of challenging here is how to rank this here. Okay. But let's try to understand the formula first, and we can now replace what we are asked to find. Please take note. How to replace and look or calculate what you are asked to find. Okay, that means our ranking here, this is the formula here, please remember, is equal to 1 minus 6 sum of d squared. Okay, now this is the formula for ranking correlation here. Of course, this one here m is the frequency of s and y. That is 1, 2, 3, 4, 5, 6, 7. That is our m here, class. Our m here is equal to 7. All right, please take note. After counting this guy, 1, 2, 3, 4, 5, 6, 7, it's still the same thing as y. That is 7 here. Now the next thing here to look for is our d, because you can find d. Listen to me, you can find d square. If I have this to be s equal to 2, s square simply means that I should square this guy here. Please take note. So if I have d, to have d square will be square the result here. Okay, so now let's have d. What is our d here, class? D is said to be the difference in ranking of s and y, like this. Now what does it mean here? It means that I have to rank this s and also rank this y here and find what? The difference before I find what? The sum of the d square here. So now let's try to sketch, or let's try to recreate this particular table here. Doing that, I will have this to be s at this point, y at this point. Okay, what are the values there? S is what? 2. Okay, call the values for me, please. What are the values of s there? 2, what again? 4, that is 7, 1, 6, 8, like this, right? Only, okay, 2. I have 2 here. Okay, Now the next thing is y. What are the values of y, please? 4, what? 7, what again? 1, 6, what again? 7, and 5, what again? 6. Okay, now the next thing here is to find arrow of S, that is a ranking of S. Now remember this, the ranking of S is always like, it can either be, listen, it can either be ascending order or descending order. Now, how do we know if I'm going to use ascending order or descending order? It means that I have to go back to the main table to know the list arrangement. List arrangement means that which arrangement is being arranged in the table there. Is it ascending or descending? The list arrangement. Please take note. Now, let's go here. This is 2, 4, 7, 1, 6, 8, 2. Ascending means that, listen to me please. Ascending means that is actually from 1 to 3. That means from down to up, right? That is from down to up. While descending means that from what? From highest to down. Please take note. From highest to down. That is descending. Okay? Now let's try to know this. This 2, 4, 7. Now what is the list arrangement here? It's what class? Ascending, right? It's ascending. Please take note. 2, 4, 7, 4, 7. So it's ascending. That is from down to up. So doing that, I will rank this guy. Ranking means that I'm giving them position. But understand that in ranking here, if I give first position twice, the next position is not going to be second again. It's what? Third. Please take note of that. Listen. If I give first position twice, the next position is not going to be second. I will give third. Please take note. This is how we give positions. Okay. Now let me give this guy. This for S here. This for S. So ranking. This will give us ascending order. That means the smallest. This will give us 1. Sorry, which one is the smallest here? This one, right? That is 1. What again? 2. Right? What again? 2. I'm ranking S. Which one after then? Which one again, please, class? I'm supposed to be give 3 here, but since I've given 2 twice, what will be the next? 4. All right. What again? 4. What again? 5. What again? 6. Please take note. What again? 7. Please take note. 7. Okay. Now I've ranked S. Please take note using ascending order. I told you how to use either ascending or descending depending on the list arrangement in the read table. Please take note. So let's get to arrow of Y. Okay. Now arrow of Y means that. Okay. Now, okay, let's go, please. Now we have ranked S. That means giving S position. Please take note. We have this to be 2. Please just be careful. Now let's rank Y. In case you don't understand the S, let's use Y to do that. Now we are using an ascending order. That means the least one will be giving position. So for Y here, this is our Y. Which one is the least one here? Please, class. 1. Right? You give it to be first position. Now the next one, which one is the second? Right? This is second position for Y. Now what again for Y? Just check for Y. Which one is the next position? This class 5. This one will be the third position. All right. Now which one is the next position? This class 6. All right. This one will be the next position. That is 4th. Now what again? That's 6. That is 4th. So since I've given 4th, I will not give 5. I'll give what? 6. Please take note. So this one will be what? This class 6. What again? This class 6. Please take note. Okay. Now let's find the difference here. That is S. Arrow S minus what? Arrow Y. Okay. Now this will be the difference between the S and what? Y ranking. This minus this. What is the answer? 0. This minus this. What is the answer, please, class? I will get minus 2. All right. This minus this. What is the answer? 5. This minus this. What is the answer? 3. Minus 3. Sorry. This minus this. What is class? Minus 1. This minus this is 4, right? 4. Okay. This minus this is what class? Minus 2. So let's get, since we have gotten D here, let's get D square. D square is going to be the square of this. Square this guy here. This will be 0. Square this guy is what class? 4. What about this guy? 10. What about this guy? Sorry? 25. Sorry. Square this guy is what? 25. Thank you for this. Is what? 9. 1. What again? 16. which one again? 4, right? Now for us to get the sum of, listen, for us to get the sum of this square means that I'm going to sum everything here. So sum everything here, this is going to be squared. Class, let's go. Sum everything here with your calculator. This plus this 25 plus 9 plus 1 plus 16 plus 4. Let's get this, please. This plus this plus this plus this plus this plus 16 plus 4. 59. So 59. So how this will be 59. So anywhere you see sum of this square, you put what? 59. So this is going to be ranking of this will be equal to class 1 minus 6 into 59. List, sorry, over n is said to be what? 7 into 7 squared minus what? 1. So let's solve this. This will be equal to 1 minus 6 times 59. Let's get the answer, please. 6 times 59. 6 times 59. We are going to have this to be 354 over 7 into 49 minus what? 1. In mathematics, for you to simplify anything in mathematics that is in bracket, simplify that first, the one that is inside the bracket first, before the outside. So 49 minus 1 is what? 48, right? So it's obviously 48. So this will be ranking here, will be equal to class 1 minus, so this will give us 354 over 7 over 40 what? 8. So let's punch our calculator. The ranking here will be equal to 1 minus, this times this will give us 354 over, sorry, 336. Please punch your calculator. 354 divide by 336. What is the answer here? That is 1 minus what? 1.0536, like this. So punch 1 minus that will give us ranking here. Please take note. Will give us 0.5. All right, 0.05, right? Then minus what? 0.053 what? 6. Please take note. So I'm having this to be minus 0.0536. Okay, now if you want to interpret this, what are you going to say? Okay, leave that on the comment section.